Buongiorno baddies, welcome back to another video. Today's first question is, point T is on sides QR of PQR, so I'm just going to call this triangle that I just randomly drew PQR. Find the ratio QT to QR if the area of triangle PQT is 75 and the area of triangle PTR is 40. So if I split this here, saying that T is somewhere randomly on this side, it does not tell us because that would make it too easy. The area of PQT is 75 and the area of PTR is 40. This means that since it is not asking us the ratio of QT to TR, we can find out the area of the entire thing, aka QR times the height that QT and QR share. Well, triangle PQT and triangle PQR share. And then we can find out what the difference is. Basically, since they share the same height, that means that they have a different base, and then we can compare the two different bases. So looking at this means that it's just, oh, that's a really bad line. Sure. This means that it's basically just 75 plus 40 for the area of the entire triangle. Therefore, the area of triangle PQR is equivalent to 115. So this means that QR times the common height that they share, divided by 2 for the area of a triangle, is equivalent to 115. Meanwhile, QT times their common height, divided by 2, is equivalent to 75. And now that we have this equation, we can start solving for the differences. So we can divide, since it's QT over QR, we can divide from this equation, and we'll get, since H divided by 2, this is all gone. So QT over QR is equivalent to 75 over 115. With a little bit of savvy solving, we'll get, so this is simplifying, so divide by 5, so 15 and 20. That's not 20, this is 23. So we'll just get 15 over 23 as our final answer. Moving on to problem number 2. In the diagram below, WXYZ is a rectangle. The area of triangle ZXA is 36, and ZA is equivalent to 3AY. What is the area of rectangle WXYZ? So, since we can know that since line ZA is equivalent to 3AY, this means that this entire thing is 4AY. And we also know that since the height of our triangle of 3AY times whatever height it is, divided by 2, is equivalent to 36. So our triangle ZXA, its area is equivalent to 36, as the problem has already stated. We can state this side as height because it is the height of triangle ZXA. And this means that now that we have a bunch of variables and a good equation, we can start writing an equation. So, if triangle ZAY, so 3AY, times the height, which is also the width of our rectangle, divided by 2, and we know that its area is 36. This means that we can solve for what AY times H is equivalent to, because since we don't have two equations, we can't solve for both variables. But if we know what AY times H is equivalent to, we can multiply that by 4, because like I said, the length of our rectangle is equivalent to 4AY. Therefore, we can start solving. So 3AY times H is equivalent to 72. Therefore, AY times H is then equivalent to, if we do a bit of solving, 24. So since we now know what AY times H is equivalent to, 4AY, which is the length of our rectangle, times H is equivalent to 24 times 4. Therefore, 4AY times H is also equivalent to 96, which means that the area of our rectangle is 96, with 4AY being its length and H, our quote-unquote H, being its width. We do not actually need to know what each one is, however it works. So the answer to this problem is 96. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye bye.